In the previous video, we have defined the fundamental node class that we can use for representing each and every node that we have inside a single linked list class, right? In this video, let's try to define the similar class that we will use for representing the single linked list as well as for adding all the functionalities that we need to have inside any linked list class. So when I explained you the terminologies that we have inside the single linked list class, right? So I clearly mentioned the very first node we have inside the single linked list class, we will call it as a head node, and the very last node we will call it as a tail node of a linked list, right? So in the linked list that we are going to implement, specifically the single linked list that we are going to implement, it is very important that we have the access to the head node. Once we have the access to the head node, right, this is of type node that we have defined earlier, right? So in this node class we will have the value and we will also have the reference to the next node. So using that next node, from the node 10 we will be able to go to the node code. Similarly, from the node code we will be able to go to the node true. Similarly, likewise, we will be able to reach the very last node, that is false. Once we reach the last node false, at the last node the next pointer that we are maintaining is basically empty, using which we will be able to say we have reached the end of the singly linked list. So here our aim in the process of representing the singly linked list, right, we have to have the access to the head node for sure. So our primary criteria that we should have inside the class that we are going to define will be head pointer should always be there, okay, and it should always point to the first node we have inside the singly linked list. And the second thing is, as part of implementing some of the functionalities such as push functionality, where we try to add the new value at the end of the singly linked list, at that point of time, if we have the access to the tail node, right, we will be able to add that new node very easily. If we don't have access to the tail node, right, first our implementation would be requiring you to go to the very last node. After going to that last node, we will be able to add the new node there. That's why, to reduce that functionality, and what exactly we will do is we will maintain one more value called tail inside the single linked list representation. So just you have to remember that the tail node reference that we are maintaining inside the single linked list, we are trying to use it in such a way that it will reduce the complexities involved in some of the operations that we implement later on. That is something that you have to keep it in your mind. And inside the tail variable that we are going to define, we will always keep the reference of the last node in that variable. Besides these two variables, right, obviously head is the first node and tail is the last node. So besides this, some of the common functionalities that we implement are insert, remove, and get and set are some of the functionalities that we will have inside the single linked list, right? While implementing these functionalities, what exactly we will do is we will try to take the index from the user. So the index, based on the value that user is passing, we will try to perform that specific operation. At this point of time, you don't have to worry, but you just have to remember that just like the operations that we have in the array, where we take the index and we try to update or insert a new value at those indexes, we will try to perform the similar operations in the case of single linked list as well. So to make sure that user, whatever the value that we are taking from the user, if it is falling in the valid range or not, we will also try to maintain the length of the singly linked list as well. So just like how tail that we are maintaining, that is making the process of implementing some functionality easier, the process of keeping track of length also will definitely help us in implementing some of the functionalities very simply. If we don't have the access to the length, right, first our job would be to our job would require us to start at the head node and traverse till the tail node, and then find the length of the linked list and use that length for implementing the functionalities. This will basically increase the time complexity. So to make sure that we are bringing the time complexity down, we will also make sure we are maintaining the length of the singly linked list as well inside our implementation. So these three variables we are maintaining inside the class that we are going to define for representing the singly linked list class. So for class representation, what exactly we will do is we will define a class called singly linked list. Okay, inside this linked list, what we will do, we will define three variables. One will be head. Remember that this head should always point the first node of the singly linked list, and each and every node is of type node that we have already defined previously, right? So we have to make sure that the node type objects are getting assigned to this. Okay, similarly after head we will also maintain the tail node. Similarly in the tail node we will always make sure whatever the operation that we are trying to perform, we will make sure that always the last node reference is available inside the tail. Similarly, this just like how we are maintaining in the head node, the object of the tail node will also be exactly of type node that we have defined. And along with this we will define one variable which will basically contain integer values, since length is an integer, right? In this length we will maintain the length of the singly linked list. Once we define that empty singly linked list class, right, what exactly we will do is we will try to add the no argument constructor. So inside that constructor, at the time of object creation, obviously we don't have any values inside the singly linked list, right? Basically it is empty. To represent that empty state, what exactly we will do is inside the no argument constructor, whatever the head variable that we have defined, right, head variable we will assign it with null. Similarly, we at the time of object creation, obviously there are no values inside the singly linked list, right? Similarly, the tail node also we will assign it with null. And since the singly linked list is empty, obviously length of the singly linked list will be 0. So we will make sure that inside the no argument constructor that we are defining, we will make sure that to represent the empty state of the singly linked list, we will assign the values like this. Okay, so that is what theoretical representation of a singly linked list class. Now let's go ahead and let's write it programmatically. So as we have understood what all variables and what all data that we have inside the singly linked list implementation, let's try to represent the same using the Java language here. So previously we created this node class inside the singly linked list, right? Now I'm going to go ahead and create a new class called singly linked list inside the same package. In this singly linked list, all the operations that I will be implementing using the node class that we have already written. So I'll simply click on finish. Okay, once we have this, if you remember the terminologies that we had discussed regarding singly linked list, right? We have three values in singly linked list. One is head, which is the first node of type node that we have represented already in the node implementation, and the second variable is of type node again, which is the last value, which we named it as a tail node. Head node and tail node. Head is the beginning, tail is the ending. Along with that, we also have the length, which basically gives us the number of nodes we have inside the singly linked list. So to represent these three values, what I will do is I will define a variable called head. If you remember, head is again of type node that we have already declared. So I'm using the same type here. Okay. Again, along with this head node, we will also have the tail node. Okay. Along with this also, we have the length of the linked list, that is nothing but int length. Okay. But when we initialize the singly linked list, then we will not have any head, tail or length, right? So we have to make sure that we are initializing with that. To initialize with that, I'm going to create the constructor singly linked list. Okay. Here in the beginning, we will not have any values. That means this dot head will be null, and there will also be any tail, there will not be any tail node also, right? Tail node will also be null, and in the beginning we have the length of the linked list also as 0. Okay, when we create the object of singly linked list, we will not have any tail or any head or tail or any nodes in the singly linked list. So I'm making sure that I'm assigning all of them to null and length as 0, so that we have a empty singly linked list object. Later on, when we try to perform the operations, we will try to adjust all this head and tail and length appropriately, so that we have a fully functional singly linked list. Okay, to validate the logic that we have written here, I'll simply be writing the main method of Java, and in this main method, let me just create the object of this singly linked list here, and let's simply try to print the head and tail and length, so that we will be able to see if the linked list is empty or not. So to do that, I'll simply create an object of singly linked list, SLL equal to new singly linked list. Okay, now system dot out dot println SLL dot head. Similarly, let's try to print all the values, that is tail, and the third one is length. Okay, now let's just execute this code. Okay, if you observe, the log that we have got is head is null, tail is null, and the length is 0. Okay, now we have successfully created an empty singly linked list. In the later operations, we will be performing different sort of operations, so that we will have the proper head node as well as tail node containing a certain number of elements inside the length variable that we have defined here. Okay, I'll see you in the such implementation videos. Thanks for watching. I'll see you in the next one.